Welcome students. In this class we will be learning the different types of mathematical functions available in Python. Now foremost, it is imperative that we know the availability of these functions. Why? Because every calculations that you come across in this area of data sciences, or for that matter big data analytics, it will involve greater amount of mathematics that you would have to perform on the data element. So if you are unaware of the available functions, then it is going to make your life very difficult, because even to add and subtract or even multiply operations such as this, if you were to use them on huge numbers, then it would take hours of calculations, and we don't want that to interfere with our major focus of completing the project. So that's why I'm going to give you all the mathematical functions available in Python with examples of how to use them. So foremost, the first mathematical operation that is available in Python is going to be the Ceil function. Now Ceil actually gives us the closest integer to the number which is represented in fractional form. Now I feel that the best way to understand the Ceil function is by means of an example. So let me do that. So I've got a program here. So it's actually calculating student average. So this is the, we're starting with the class, and then we will start off with the method, the init method, and then after this I will just give a print statement. Print, please enter student marks. So we are actually getting in marks for 3 subjects. So I'm going to say self dot mark 1, and then I will take in a float value, float of input, and then I'll copy this and then I'll paste it. So I'll change it. This is self dot mark 2, this is mark 3. So next is I would want to calculate the total. So total is equal to self dot mark 1, and that has to be added with mark 2 and mark 3. So let me change that to mark 3 and mark 2, and print the total. So print self dot total. Now after I have printed the total, so I will say you have secured str of float this should also be float, and the conversion takes place and the output is printed. Okay, that's fair enough. Now I would like to make a decision here. If the student gets greater than 77, right, then he is accepted into the program. If he falls short of 77, he is not accepted into the program. Okay, if dot total is greater than equal to 77, then you print you are accepted into the program, and probably you can exit it. If not, I need to give a else. I will say you are not accepted. Print, I will say you are not accepted. I need to create a class, say student is equal to average, and we are instantiating it. And so if I were to run the program, it will ask us to enter the student's mark. I'm going to enter 25.5 and then 0.4 and then 0.3. Now the output, you can clearly see he has secured 76.2 and it says you are not accepted into the program. Now this is where the ceil function comes into play. Now the student falls short by 0.8 marks. Now is it fair enough to push the student into a category of not being selected? Or in other words, just because he or she has fallen short by 0.8, is it fair to deny them the opportunity to pursue the program? Because 0.8 in the case of finding averages, it's not all that big score, 0.8. So we can actually put in a requirement or put in a condition in place where if a student gets anything above 76, you take him into the program because he or she has made that effort to come all the way, right? Given the challenges that he or she would have faced, So we need to place in that element of humanity in accepting the student, even if he or she has fallen short by 0.8 or even in fact 0.9, that's fine. So we have to design that or put that system in place. So what we have to do is ceil function provides us, this ceil function which I'm talking about provides us that opportunity. So how are we going to implement it? Now I'm going to just put in total 1 there. So I'll calculate that. Then I'll say self dot total is equal to ceil. So now to obtain ceil or to use ceil, we need to import the mathematical library. So I'm going to say from Python, so import math, that's fine. So once we have imported, we can use it. So this is going to be math dot ceil. So this is how we have to use of self dot total 1. So we are getting the ceil. So what a ceil will do, now we got the 76.2, right? It will immediately convert 76.2 to the nearest integer, which is above 76.2. So what is the nearest integer? That is positive integer. Of course we are talking about positive integer. The nearest positive integer above 76.2 is going to be 77. Simple as that. So 77 would be taken. So that would mean the student would be selected, right? So this is where the conversion takes place. The conversion is stored in this particular variable total, and then it is printed, and then the test is made, the conditional check is made here, and this would be the output. So let's see that. So I'm going to run it. I'm going to give in the same input 25.5 and then 25.4 and then 25.3. Same thing. I'm going to run it, and there you go. You have secured 77. You are accepted into the program. That's fine. So this is how we use the ceil function. Students, we will go on to learn the next function. So the next function that we will be learning here now is what is called as the floor function. Now let us understand, as usual, this particular function using an illustration. Now let us think about a situation where an old aunt is walking into a supermarket and buying in 3 products. So that is the scenario, and what we will do is we will try to convert that scenario into a program. So this is the program we did for the last illustration. I would want to reframe it. So in this case, the first line is please enter the product price paid by customer. So this is to the cashier, right? So the teller is actually entering the prices received from the customer. That's from our old aunt. So this is going to be price 1, and this is price 2, and this is going to be my price 3. So 3 prices are already been received, and we are adding them. So let me change these variables. So price 1 plus price 2 and price 3. Okay, so now if I were to print it up, let me just print this up. Print self.total, that's fine. Now say for example there is a tax on the product, so tax is equal to self.total 1 times 0.001 is the tax that has to be paid on these products. So now the sum gets changed, right? So self.total is equal to self.total 1, and to this total 1 we need to add the tax, and that is what is being printed. So now the goods would only be given to the aunt if what the aunt has paid. So we need to obtain that. So this is the payment from the aunt. So let me just say total received from the customer. This is the total received, and this is the total from the teller. Okay, so along with the tax. Now we need to make a check. What is the check? I don't need this. The check is if the total received from the aunt is not equal to the total calculated by the teller, right, then your products, this is a message coming, your products cannot be delivered. Right? Why cannot be delivered? Because payment not complete. Payment not complete. Probably we can also give the customer the payment that he or she has paid. So print, I'm going to say you have paid this amount. So that's going to be plus str of self.total received from the aunt. So let them also know how much they have paid and why the supermarket doesn't want to deliver the goods. You know, the truth is revealing, so that is critical. So now I'm going to show you what happens here, and there is a else statement, else your products can be delivered. If this is not the case, I can say products else payment complete, payment completed, products delivered, right? So this is the message that is printed. Okay, now let me run one more check to see if everything is fine. So the float here, so the total price, so let me also convert this into float, otherwise I will have a problem. So that's converted, and sales tax, this should also be converted. And okay, so that comparison is fine. This should be total received, right? So this is the tax, that's fine. I'm calculating the tax here, converting it into float, and then taking the money. So this should be total received plus tax, and then there is the comparison. If the total received is not equal to the total produced by the teller, fine. So let me run it. So I hope you got the idea. So please enter the product price paid by the customer. So I'm going to use the same 25.5. So the aunt pays 25.5 for the first amount. For the second amount, 25.4. That's $25.4 4 cents, and 25.3. So $25.03. Now you have paid 76.2. Your products cannot be delivered because payment not complete. Now, why the payment is not complete? Let us also publish that. So I need to also produce this tax, or I would say that print statement with the tax. But the total with tax is, so this is the total with tax plus str of self dot total from the teller, right? So let this also be printed. So I'm going to run it. I'm going to take in that same thing, $25.5, $25.4, and $25.3. Now if you were to run it, you see that you have paid this amount, $76.02, but the total is what? $76.27, and it goes on. Of course, we can round this off. Probably in the another function, I will just show you how to round it. So now the aunt has paid $76.20, but the supermarket wants $76.27. That means the aunt doesn't have that 7 cents, right? Imagine. Now the supermarket goes to the extremities of behaving in a monstrous manner. Products cannot be delivered, so the cashier is not going to let the products pass through the counter. So this is where the element of humanity should come into place by business centers, specifically supermarkets. They should not be holding on to small changes like 7 cents, 8 cents, things like that. No, we cannot also blame them, because the program writers should take these things into notice. So how are we going to change it to benefit the customer? Of course, we are not giving them a huge pie or a donut. After all, the supermarket is just going to waive 7 cents. That's no big deal. So there should be some changes present here. I will have to make the changes in the tax. So this is the tax calculated by the teller. So what I will do is I will say self.total from the teller is equal to float of math.flow. So I will take the flow for the amount that the teller produces. So this is going to be self.total from the teller. So now in this case I'm going to make a check. If the total received is greater than or equal to the total receipt from the teller, you have paid this amount. So now what are we doing here? Now okay, we are calculating the tax here, and we are adding that particular tax to the amount received. So this is the amount from the teller. Now there is another thing that is going on. What are we doing here? Teller 1, we are taking the floor of it. Floor means if it is 76.72, we will just take 76. So the nearest integer, which is lesser than the amount that is displayed. So that is the exact meaning of floor. Now we are checking here. If amount paid by the client, if it is greater than or equal to the floor amount, and then you simply say everything is fine, and though the tax is this much, yet we are happy to deliver the goods. Simple as that. I hope you understood the logic that is going on here. So let me just run it. I'm going to give in the same value. So the aunt is paying $25.5, $25.4, and then 0.3 cents. Now clearly we know this is short of the requirement from the teller, but now the message given would be totally different. So you see that you have paid this amount 76.2, but the total with tax is 76.27 cents. Your product's delivered. Thank you, payment complete. You catch the point? So that makes everybody happy. Though it is a small, it's nothing. 7 cents is nothing, but yet the supermarket wins a customer. So that is how we use the floor function, students.